Welcome to the Cosmic Pie Podcast, Season 2, Episode 12. I'm your host, Wayne Barkhouse, and with me is...
Robert Moore.
So, Robert, we're going to have a special guest, as
Yep.
we kind of alluded to in the description of this podcast. So, before we introduce our guest, we just want to make mention that we do have a live chat that's running. So, if you have any questions or comments that you'd like to make throughout the podcast, please feel free to use that. Also, a disclaimer, what any of us say, including Robert and I, are our own personal opinions and not necessarily that of any other affiliation of any institution or whatnot.
Yep, just us.
We are broadcasting live here from the campus of the University of North Dakota here in Grand Forks, North Dakota. And with us today, our guest is Dr. Dean Smith. Hi, Dean. How are you doing?
Hello. I'm doing pretty good.
So, Dean, the big thing going on in astronomy, in case somebody's living under a rock, and you don't want to be there, and when this event occurs,
Absolutely not.
You'll miss out, is, of course, we have the big total solar eclipse of the sun that'll take place on Monday. So, Dean, would you like to take over and maybe let us know what that's all about?
Yeah, so I'll talk a little bit about this, and yeah, it's kind of hard not to know about it. It seems like it's in the news a lot now.
It is.
And there's emergency declarations in parts of the country. So I'm going to start out doing a simulation just to kind of show what to expect.
Okay.
So we'll see if this works. So I'm sharing the screen. Let's move that over there. So this is a stellarium, which I think a lot of people are familiar with. I've used this in the past. So this is set up right now for Dallas, Texas, and we'll kind of look into the times and where you need to go and all that. But the times will be different. Very roughly, maximum eclipse is going to be about 2 p.m. Central Time, but it depends where on the path you are. So I have this set for I think about 1 p.m. and this is in Dallas, and I'll just animate this. So we'll kind of just we're looking at the sun right now, and what an eclipse is we have the moon passing in front of the sun. I think most people probably know that. This doesn't happen all that often. Obviously, it only happens during new moon. So new moon is when the moon is between us and the sun. But normally, the moon is above or below the sun. It misses it. So the orbit of the moon is inclined about 5 degrees. So normally it misses. Every once in a while, it happens to pass right in front of the sun. Most parts of the globe, the Earth, are not going to see the total solar eclipse. They're going to see a partial eclipse, and so the moon will kind of cover half. I think from Grand Forks here, it's roughly 60% is covered, and so most of the country you're not going to be able to see the total. So why do people care about the total? Mainly, in the total eclipse, you can see the corona. And this is the simulation of the corona here. This is the outer atmosphere of the sun. This is the only time you can see it. We do not have, you can't buy a special telescope to see the corona whenever you want. So, and so that's why people travel and to see this is to see that corona. So this is the view from the Earth. If I zoom out, now, the eclipsed sun is still pretty bright. It's brighter than the full moon. And so it doesn't really turn day into night, but it is darker. I was at the 2017 one, so I only have experience with one other total solar eclipse. And I actually brought a digital thermometer with, and it did, the temperature did drop by over 10 degrees Fahrenheit. So it does cool down. It does get darker. You can start to see the brightest stars, brightest planets, but it isn't night. It was dark enough that street lights would turn on. So, and So that was kind of interesting. If you have street lights around you, you probably notice that they'll turn on. It seems dark enough for that, but it's kind of a twilight, between twilight and a full moon.
Right.
Um, so
What what I found neat was looking around the horizon. You could see essentially sunrise, sunset everywhere around you. You know,
right,
type effect, and that was
yeah,
kind of neat.
yeah, it's like a twilight, 360 degree.
Hmm.
Yeah, like a sunset view, and then overhead it's kind of this dark blue.
Right.
It's not black like a lot of pictures. Pictures don't do it justice. I can say that.
Right.
This was, I've seen lots of pictures of total solar eclipses, and the one in 2017, you're not really prepared for it. So
Yeah, so Dean, what you're talking about here is not that the sky is black, but anytime you see a picture of a solar eclipse, the side of the moon that faces the earth looks totally black. But that's not what you actually see with your eyes. What you
right,
see with your eyes, you can actually see the near side of the moon and its features, and it looks this sort of beautiful blue like color, dark blue that you could see. And it's very, very difficult to capture that, as you mentioned, using like photography. In fact, I've only seen one image that somebody, used sophisticated settings, was able to capture the view that's pretty close to what I've seen with my eye back in 2017 during that total solar eclipse.
Well,
and
people
those
forget that the
pictures.
eyes. Go ahead.
Oh, yeah, it's difficult to get things because if you want to get that blue color in the sky, you end up overexposing the corona.
Right.
And so there's a challenge. You
It
basically have to combine pictures of different exposures.
the bottom line is the camera. We haven't invented a camera yet that can replicate the dynamic response of the human eye.
Yeah, dynamic
Right.
range,
The
as they would
dynamic
say.
range. Yeah.
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 So
Yeah. So if you haven't seen one, don't think that, the pictures have prepared you. Yeah, it was it it's I I think I can say it's the most amazing thing that I've ever seen. Is a total solar eclipse.
Well, when you first
So
when you see one, Dean, I mean, you can then think about how there's a certain group of people that go and chase these eclipses all around the world. Like they spend the money to travel to distant lands to get into the path of totality so they can see the total solar eclipse. And you can understand after you see your first one why they do that.
right. It
yeah,
really
yeah,
is impressive. Yeah.
that 2 minutes in 2017 wasn't enough,
Yeah.
right? Like it doesn't last very long. Now the one this year, if you're near the center line, you could get 4 minutes. That
Right.
still isn't very long. Um, when the eclipse happens, there will be some bright planets, so you can probably see Jupiter and Venus in the sky. So you can look for those. Venus will be to the lower right, Jupiter to the upper left. It's possible there will be some other planets if I turn the atmosphere off, which you can't do in real life. There is Saturn and Mars to the lower right. I don't, you could look for them. There's a lot of news reports. There's a comet. In fact, in my background is a picture I took during spring break about a month ago, the Andromeda Galaxy and Comet Pons Brooks. So that comet in the picture behind me is the comet that will be out during the eclipse. I doubt it will be naked eye. There's some news stories saying you might see a comet with the eclipse. At least I haven't seen it since about 3 weeks ago. Then I needed binoculars, and that was in a dark sky.
Right.
So remember, total eclipse sun, that is
About
brighter than the full moon.
brighter than full
So,
moon. Yeah.
but there will be the comet. It's near Jupiter. It might be visible in binoculars. You have to decide, do you want to take time from that 4 minutes of totality to look for a comet that you could see in the night sky now, and and probably get a better view. So, um, yeah, that comet is out. It's very low after sunset. So, um, so it's a challenge to get the comet now. It's kind of getting into the twilight, getting closer to the sun. So
We have a question. Bill Schwalm asks, I saw a total eclipse when I was once when I was a boy. I seem to remember the moon was red. Is that possible?
I
would
wouldn't expect the moon to be red
That
in a
reminds me of
solar
a
eclipse.
lunar eclipse.
a
is
lunar
definitely-
eclipse,
Lunar
it gets
eclipses,
red.
turn red.
Yeah,
Yeah,
And that's when the Earth's shadow goes on the moon.
yeah.
yeah. Those last for a lot longer too because the Earth's shadow is a lot bigger.
Well, and then there's
Yeah.
part of that is that the sun during a lunar eclipse refracts through the Earth's atmosphere, and it's predominantly the longer wavelengths that get to the moon's surface and reflect off it back to Earth.
Yep.
So that's what gives us its reddish color. In fact, you can use the color of the moon during a lunar eclipse to actually say something about the composition of the Earth's atmosphere at the time,
Mm-hmm.
and people study that.
Now,
Yep.
the moon is slightly lit up, and the longer exposure pictures will show features on the moon during a solar eclipse, and that's from Earthshine.
Earthshine.
Yeah.
Uh,
And that's
from
what
the point of view of the moon, it's seeing a full Earth.
and that's what you can see with your eye.
Right.
Right, if
Right.
no light came back to your eye, it would look black, but it's not black. It looks this dark, sort of bluish color, and that's the reflected light from the Earth back to the moon, then back to the Earth again.
You can put this in contrast by referring to something called albedo, which is how reflective a body is, and Earth has an albedo of about 1/3, so it reflects 1/3 of the light that it receives. But the moon is actually dark. Its is around 60%, so it's much darker than Earth.
Right. So the amount of light reflected on the moon is what? What are 5% or 6%?
Yeah, something like
Yeah.
that. It's I mean, you look at the moon, it's mainly andesite and diorite,
Yeah.
basalt. And if you pick up a chunk of andesite or basalt here on Earth, it's dark. So Earth actually reflects much more light. You can see the moon reflecting that light back to Earth, and it's called Earthshine.
Or just think of Venus, where it's completely cloud cover.
Right.
The amount of light that's reflected off the surface of Venus because of very high albedo,
Hmm.
reflectivity. A larger percent of the photons get reflected back off
That's
the
exactly
clouds.
what's going on. Yeah. So,
Now, Dean, you mentioned just some of the stuff you talked about already, the fact that we don't have a solar eclipse when the moon is at new moon phase every month. Do you want to explain why that's the case?
Yeah, well, that's basically because the orbit of the moon is inclined about 5 degrees relative to the Earth's orbit around the sun. And so most of the time, the moon is going to be, a little above the sun or a little below the sun, so it just misses. And the moon is further away than a lot of people think. A lot of people don't have a good idea of the scale.
Right.
So they think 5 degrees. Well, that's not much. You can fit 30 Earths between the Earth and the moon. So the moon is a pretty good distance away, and so that little 5 degrees is enough so you don't get this alignment. And it's a very precise alignment that the moon is almost exactly the same apparent size as the sun. It's it's a bizarre coincidence that the sun is 400 times bigger than the moon, and it's also 400 times further away. And so they kind of just match up. So that's why the totality is kind of this, perfect match. It's this thin, band on the Earth to see it. But even, you don't get partials that much. That 5 degrees is enough to throw it quite a ways off.
right.
Um,
Angular size, they're only about half a degree, aren't they?
Yeah, they're half a degree.
yeah.
Yeah, that's probably another way of thinking of it. Yeah, the sun's a half a degree, and the moon's orbit is inclined by 5 degrees.
Right.
So much more than the size of the sun. So the sun's a small target
Yeah,
to cover.
So you could get 10 moons above the sun and 10 moons below the sun, depending on which way that 5 degree works out at the time that you're looking. So most time it's going to go above or below the sun and not right straight through the middle line that you would block it out totally.
Right.
The other interesting thing is we know the moon, because we can measure this with lasers off of reflectors left on the surface for back in the Apollo program. We know that the moon is moving away from the Earth all the time, very slowly. So that means the apparent size of the moon is getting smaller and smaller. So in the distant future, and I mean distant future, millions and millions of years from now, the moon will be far enough from the Earth that it will never totally cover the sun, and we will never, at that moment onwards, never have a total solar eclipse of the sun. It'll always be angular
Annular.
eclipses. Yeah.
Annular. Yep.
Yeah, so you just get the ring,
The ring of fire.
Which
ring
means
of
you'll never
fire.
see the corona during a total solar eclipse.
Right.
Yeah.
Now that's a
So
long time from now, but still it's an interesting fact when you think about it. And the other thing in your simulation that you showed from Dallas, as the moon's approaching the sun, you get a real feel for the orbital motion of the moon itself, that it's going from west towards the east. And you
Right.
can see
right.
that in the direction that it's coming from on the right as it's heading to the left. And so that's really what we're seeing there is the reflection mainly of the moon's motion as the moon orbits the Earth.
Yeah, and the path of the shadow is always from west to east.
Mm-hmm.
Because of that, I know some people get a little confused because they think, well, the sun is going, the other direction. But that eclipse path isn't the path of the sun; it's the path of shadow. And so,
In fact, you can note this, and Dean, you know this because we do this as a project in our first year astronomy class, that if you just go out some night and note where the moon is relative to the stars, assuming the moon is viewable, and then just go out at exactly the same time the very next night, assuming it's clear, and note where the moon is. It's not going to be in the same location. It's actually moved further east. So night
right,
after night, the moon goes further east, further east, further east, because it's actually orbiting the Earth in that direction.
Right.
right, yeah. So the moon's above the horizon a little longer than the stars because it's kind of moving in that opposite, toward
Mm-hmm.
the east.
Yeah.
So I do have another simulation, and so this was a stellarium. See if I can bring up. So this is a different program called Celestia, and this is the view right now of from the Earth looking at the sun and the moon, and I'm just going to turn it around, and so we get the view if you're on the moon looking at the Earth. And so if you're on the moon, and the phases are always opposite, and so if you see a new moon on the moon, you're seeing a full Earth. That's right. And if you see a crescent moon, that means people on the moon would be seeing a gibbous Earth. It's kind of the opposite phase. And so this is the view from the moon during the eclipse, and you probably see the shadow. So from our point of view on the Earth, we see the moon moving in front of the sun as an occultation. And from the point of view on the moon is casting a shadow on the Earth. And so you have to be in that shadow to see the eclipse. And only the very center is the total. The outer parts, you're going to see a partial. And now we'll see, I'm going to animate this live, so we'll see if it actually works. So, and we see the Earth kind of rotating, but because the moon is moving, we get that shadow kind of moving off to the east there. And so that would be the path. And this has been seen. So this is a simulation of, the path of the shadow. So kind of going from Mexico up through, Texas, Illinois, Indiana, Ohio, New York, then up into Canada. So that has been seen. There's in 2017. Let's see if I can bring that up. Oh, I have 2017. This was seen. This was using the Discover satellite, which is still there. It's in the Lagrange point between the Earth and the Sun, and so this is the shadow. And if I pause it, you can probably see it there. So this is the shadow here, going basically from Oregon and then east across the United States. So this is not a simulation. This is actual pictures. And so this satellite is in that Lagrange point, like I mentioned. Might have heard Lagrange points like the James Webb is in one. That's in the other one opposite, on the other side of the Earth from the sun. So this is the between the Earth and the sun. It's about 1 million miles away, and it just sits there. And it has a camera pointed at the Earth, and so it's able to get these pictures of the Earth. And so from its point of view, it's able to see. So this is from the view from 1 million miles, about 4 times further away than the moon is of the shadow. And so we'll probably see another animation. Hopefully, if the satellite works, we'll see another animation of the shadow after this eclipse, and hopefully it looks like the one that I just showed. So, that's the view from the moon. You see a full Earth with the shadow. Big difference with the lunar eclipse. And the lunar eclipse, I didn't come prepared with simulations
Okay,
for
so
that, but
so before you jump to that, Dean, so a couple things to note. Number one, I think the astronauts on board the ISS back in 2017 photographed a shadow on the
Yeah.
Earth, and we'll
right,
we'll probably see the same thing this time around. And the other thing to note here is when you look at this image, the shadow, you might think that whole area is going to be experiencing a total solar eclipse, but it's not because it's hard to see in this simulation, these images, I should say, put together as a little movie clip. It's hard to see the umbria part of the shadow and the penumbra part. So you want to be in that central region, which means that the distance that you have to be to see a total eclipse of the sun is relatively small given the size of the whole shadow, if you like.
Right.
right. Yeah, so if you're seeing a partial eclipse, part of the sun is covered, and so you are in this, penumbra, the outer part of the shadow. Yeah, and it's hard to see here what that is. And so if you plan on seeing the eclipse, you do want to make sure that you see that. And I can jump to my other uh, part here. Got a little PowerPoint, and I put some notes because these are things I want to make sure I mention. It's easy to forget. So one thing, and these are things that I've heard. People, some misconceptions. If you want to see that corona, the outer atmosphere, and that's kind of the main event, it's not the only thing, right? Seeing that 360 twilight is also cool. Um, you need to be in the 100% covered path. And in 2017, I was overhearing people saying, well, they live where it's 99%. That should be good enough.
Nope.
So
It will not be. No.
1% of the sun is bright. So 1% of of the sun showing, that's going to overpower the corona. Um, During the partial phase, or if you're outside of that, right? If you're in North Dakota, you need eclipse glasses for the whole thing. During the partial phase, that's the whole time except for the 4 minutes. And it takes about an hour. So there's about an hour for the moon to cover the sun, then you get 4 minutes of totality, and then another hour for the moon to leave the sun. So you needed glasses during that whole partial phase. If you're taking pictures, you need solar filters on the camera. So and so you need all that. When you get close
Dean, do
to,
you want to?
oh yes,
Sorry, do you want to tell people why you need solar eclipse glasses to look at the sun during the eclipse, and not the total phase, but the partial phase? When on an ordinary day you can look up at the sun, just little glances at the sun, right, and you're not going to damage your eyesight. So, can you remind people or let people know why there's a difference between looking at the sun during a partial eclipse phase versus just looking at the sun in an ordinary day when there is no eclipse going on?
well, you shouldn't look at the sun during an ordinary day
Well,
either.
the
Um,
fleeting glances is what I'm
Yeah.
saying, right?
yeah, well, yeah, well, the eclipse isn't any more dangerous as far as I know. Um, but you're more likely to be, it's not going to be a short glance, right? So people are going to be trying to actually see the moon in front of the sun.
Right.
And
And the
so if
other,
you're actually staring at the sun trying to see the moon, that's not a good idea unless you have
yeah.
eclipse glasses.
The other thing is even though, because again, that dynamic range of our eyes, your pupils dilate as
Yes.
it gets darker. And so that's letting in more light. And if you try looking at the sun, it'll burn directly into your retina.
Oh, okay, yeah.
Yeah,
If you're
that.
trying, if you're
Yeah.
trying to look
And
during, the very sliver
and
parts. Yeah.
that's why I also recommend during totality that you set a timer. It's going to be about 4 minutes long, so set a timer for 2 minutes. You can glance up and glance away, glance up, glance away for that 2 minutes, but then to make sure you're not going to overlap where the sun starts appearing again, set that timer. Let it go off at, a minute before the totality ends so that you're not looking at it.
Yeah, I remember 2017, when we looked at the total solar eclipse, I was down in Nebraska at the time. That was one of the things I had to watch out for. Is just when the eclipse was over, you could just start to see. You immediately got to remember to turn away so you
Turn
don't
away.
damage your eyes. But in a little bit, you're playing, the odds a little bit. You have to be very careful
Yeah.
what you do there. I could see some people not realizing and stare at it for a while and then cause major permanent damage.
That's
You might not know it's ended.
right.
Yeah, they
Yeah.
have that little sliver, and it's probably worse after because it gets dark and your
Yeah.
eyes, your
Wide
pupils have
open.
opened up,
Yeah, for
and
sure.
yeah, it's wide open. Suddenly, you're gonna have that sun shining at you.
And just as a public service announcement, if you like,
Yeah.
I remember back in 2017, I forget the person's name, and I wouldn't say it anyways if I remember, a famous, I think he was a singer, like a rap singer, who after the eclipse made a statement to the news media that he sees a permanent image in his eyesight of the partial eclipse, that he thought that the warnings that people had given out, that he had heard, were actually a bunch of bunk. So he
Right.
stared at the sun during the solar eclipse and actually damaged his eyesight. Now, that was in 2017. I don't know if it recovered since then or not. So, these announcements that come out to warn people are there for a reason.
Right. Again, you can look at it while it's in totality, but you need to set that timer and look at it with eclipse glasses till you can't see the sun anymore. Hit that timer. It's 4-minute eclipse. Set it for about 2.5 minutes. When it goes off, stop looking.
Yeah.
Otherwise, you'll damage your eyes.
And the other thing is, of course, don't drive with your eclipse glasses on.
Absolutely not. if you can see anything through the eclipse glasses except the sun, they're not good glasses. Do not use them to look at the sun.
Yeah,
But
kind of test them out. Look at a light in your house or something. Make sure nothing's getting through.
if
Um,
you see
yeah.
that light, it's not the glasses are no good.
And for those of you who may have eclipse glasses laying around from maybe back in 2017, I was looking at a pair that I still have home. They actually have it written on them, do not use them after a certain period of time,
Right.
to be on the safe side. So, and that,
really?
I think it was a year or two afterwards. It's written on the glasses themselves. So you want to be very careful. Maybe it's worthwhile to have a new pair. So I went out and purchased new glasses
Yep.
for this eclipse just to be on the safe
And-
side, because it is your vision we're talking about.
We have another question from Bill. What about the photo or a pinhole image? And I think that's what you've
the
done with
picture
this.
in my PowerPoint. Yeah. So this was a card with a small hole in it. So during the partial phase, this is in 2017. During the partial phase, we were trying all sorts of things. In fact, and so we had some cards with little holes, and we had some white paper down on the ground, and so we could project. And there's all sorts of ways of doing this. So that this was, just a card with a hole in it. You can see in my hand there was a gap between my fingers, and so there's another crescent. And not intentional. So any small hole, some people use colanders, and then they get a whole bunch of images of the eclipse. Sometimes in trees, just the gaps through the leaves, you'll see a shadow, so the shadow of the leaves, you'll actually see crescents. And so there's all sorts of ways of kind of projecting this crescent.
So Dean, here's another way, Dean, and I don't know if you heard this before. You can use a soda cracker, the little pinholes in a soda cracker.
Yeah, that should
okay.
work too.
Yeah, that actually works. People actually use that.
Yeah, so there's a lot of different ways of kind of projecting this.
Yeah.
So other things to notice when you get close to totality, when you got the crescent, kind of like what's here, the shadows will get really sharp.
Right.
So just kind of look around. Things start to feel weird because normally the sun has some size to it, and there's a little bit of blurriness to the shadows. But when you get down to that last 10 minutes, the shadows will be really sharp. Everything is eerie, right? It gets darker.
For me, it
the
got
shadows
greener.
are weird and sharp. So kind of look at that stuff, leading up to totality. The other thing, if you're taking pictures, you're going to want to be setting your camera settings, making sure everything's ready to go. So I mentioned shadow bands. Those aren't always seen. So that's actually why this white paper was down on the ground, was an attempt to see shadow bands. So when basically in that last, like maybe 5 minutes before totality, when the sun is a really thin crescent, uh, and I forgot to actually bring a picture. There aren't a lot of pictures of them. It's hard to get pictures of them, but you basically see these kind of gray and white bands. They're low contrast, but you can see them on a white sheet of paper. We saw them a little bit on a white vehicle that just happened to be there. And so they're hard to see. You don't always see them. It apparently depends on atmospheric conditions, so you may or may not see them, but that's something to look for. So we kind of talked about the last part, but you definitely, if you want to look at the corona, you do need to take the glasses off, right? So those eclipse glasses are too dark to see the corona. And so there is that totality where you do want to take the eclipse glasses off, so that way you can see the corona. If you're taking pictures, you have to take the filter off the camera. You're just going to get dark. So um, and so you do need to take the filters off when you're taking pictures during totality as well. So you'll see the sun's corona against the dark blue sky. Jupiter, Venus, I mentioned. If you got good eyes, you might see prominences. And so we had, people, I think, younger that have better eyes than me, were able to see. There was a big prominence on the sun in 2017 in the upper right that people were able to see. I will mention about the timing. I paid $2 for a solar eclipse timing app, and so it'll actually announce when totality has started, and it actually warns you, like, put your eclipse black glasses back on. So you have the timing there. So that's also available if you want, you know, know the exact time when you can take them off and put them back on.
Right.
There's a little, $2 app out there.
Do you remember what
Uh,
the name of the app is? We're not
I think it was
promoting
just
them,
called,
but just wondering.
yeah, it was called Solar Eclipse Timer.
Okay.
I don't know if there's other ones. I'm making sure I got the right name. Yeah, it's just called Solar Eclipse Timer.
Okay.
And the one I had, it was $2. We used it in 2017. It worked great. It was well worth it. So
Yeah.
it was
Okay.
nice. It was nice having the updates. Like, it counted down, so you knew, like, exactly when totality was starting. It would tell you, look for diamond ring. Actually, yeah, so it's a nice little thing to have on the side. And pretty small price compared to how much I'll be paying in gas, and
Yeah.
so
Right.
Well,
just to get to the thing.
yeah, we were talking before about when it was a totality, the one I was
Yeah.
showing you from Big Kids Science, I think it is, that AAS, the American Astronomical Society, is sponsoring, I guess, or approve of. And that actually will tell you where you need to be and how to get there using Google Maps to get to the path of totality. So if you're within, I don't know, let's say you're in the middle of nowhere and you're 10 miles away from the middle of the path of totality on a dirt road, it'll actually inform you where you need to go to get to that path of totality, which is really,
Cool.
really
That's
handy.
good.
Yeah, and
I
you
don't know if
probably
it,
want to be
yeah,
prepared to drive, because you can't, if it's cloudy, you'll want to be looking, at a satellite map, see where it's clear.
that's why
And
you should have
so,
at least two people, like you and someone else, so someone can do the driving, while the other one's doing the navigating based on the
right,
cloud cover.
yeah,
Right.
see, yeah, because you might have to y- travel, and the weather in most of the United States right now isn't great. So,
Right.
um, So, uh, if you want to see where to go, timeanddate.com has a nice map. This is just a screenshot, but if you go there, this is a zoomable map. So you can zoom in, see the cities. If you click a place, it will tell you how long the eclipse is at that location. So if you're right on that dotted center line, you get the maximum. You don't have to be right on it, um, but you don't want to be on the edge either. So you do want to be uh, kind of, within the darkest band in the middle there. Everywhere outside of that is partial. So you want to be within that width there. Um, So, but you can go to that website, kind of zoom in, find places.
Hmm.
Um, and there's there's also a weather app. I forgot what it was, but Chris Milford's on the chat. He can tell me. So it was like my radar. He's the one who told me about it. So I download. Oh yeah, it's just called My Radar. That's it. So it will give you a satellite map of the clouds and also show the eclipse path on that satellite map.
Oh,
Um,
nice.
Nice.
so that's a nice way if you're looking for a clear, hole in the clouds. Um, so it's another way of traversing. So, but yeah, don't get too set on a location. You might have to, chase clear skies.
Right.
So, so this is a good place to figure out where to go. I've been checking this for the weather forecast. So this is pivotalweather.com. You click on the eclipse and it brings up, this is a little backwards than you expect. White is actually clear and blue is cloudy. So, so it's backwards from what you expect. This changes every day. Um, I have noticed different weather forecast websites are giving different, we're a week out. How often is the weather forecast good a week out? So, so don't, you know, this is a guide if you're still making plans, but things can change a lot in the weather forecast in a week.
Right.
So, um,
Yeah, and
so, but
based on climate data, so the best place to be would be in Texas or in New Mexico if you want to go into another country. The worst place you'd want to be was in the Northeast. And then
right,
the weather as it stands now is actually the flip of that. Right now, the Dallas and Texas areas forecast for bad weather, overcast skies, even rain and thunderstorms. And it's clear as you get, sort of off to the Northeast. But like you said, there's still a few more days away, so that can change.
yeah, yeah. Weather forecasts usually aren't too good a week out, but this trend has been showing up for a while
For a
now.
while.
So, so it seems like this is at least the general trend. And yeah, it is opposite. Everybody was looking at the historical chances, how many days out of the last so many years was it cloudy or clear? And it's the opposite of the conventional wisdom. So,
Well, I mean, that's
um,
just obviously we have fluctuations, right? Just because the climate data over the last 20 years says the odds are certain, it's obviously you can
yeah,
deviate from
and
that significantly. The thing I'm kind of curious about is how many hundreds of thousands of people plan to go to the Texas area that all of
Right.
a sudden is starting to panic and think about getting last minute into the Northeast as fast as possible. Hopefully they got
yeah,
cancellation insurance on their flights. They changed their plans at the last moment.
Right.
yeah, and that's the hard thing with an eclipse is you make plans way in advance, but you have no idea what the weather's going to be. And none of this was really good. Even in Texas, I think historically it was like 50-50. So there was no like, place that it was like, okay, this is going to be for
This
sure clear.
this is gonna be sweet. Right.
Even in Texas, it was a coin flip, right?
Yeah,
If you're going to have clear skies.
I think you had to go into Mexico before you had like a 20% chance of cloud cover,
Yeah,
Right.
like those kind of odds. But a really interesting place in all of this, at least from my personal opinion, is Niagara Falls, because the path of totality is going to go right over the falls.
Right.
And what a backdrop if you can somehow get, superlay the solar eclipse with the falls and stuff. And I know Niagara Falls, at least on the Canadian side, I was reading about earlier today, they've declared a state of emergency already for the
oh
amount of
yeah,
Yeah,
traffic they're
they're
expecting
expecting
from,
like over 1 million
yeah, well,
people.
people from like Toronto. And Toronto is just north of the totality path. So people in Toronto, they'd actually have to go somewhere else. And you can't go south because you're into Lake Ontario, which is difficult unless you have your own boat or something, right?
Right.
So you're going to have to go west and drive around the lake to get to essentially Niagara Falls. So the traffic is going to be unbearable. It might be easier to do the rail, the via rail, if you're in Canada and Ontario, southern Ontario. But yeah, it's going to be a nightmare in terms of traffic.
Yes.
So for at least for the sake of those people and the hardship they go through, I hope it is clear weather, at least clear enough that you can see the total solar eclipse.
Right. Here's
oh,
hoping.
and I see Millie Milford mentioned something important in the chat with the eclipse glasses. Don't look through a telescope or binoculars while wearing the eclipse glasses. So if you're and you can have you can look through a telescope or binoculars, but you have to have solar filter material over the front of
You
the
want
binoculars or the telescope, not on your eye at the eyepiece, because all that light is being focused. The eclipse glasses are not designed for focused sunlight from a telescope or binoculars.
right.
So you can get filters that go over the front of them, and that's how you would have
You
to do it.
you want to reject the light before it gets into the optics, not after.
Right.
Yeah, that's
Right.
that's why I'm always thankful that I still can see, because when I was a young kid, I purchased one of those Tasco telescopes that had the solar filter that you screw on at the end of the eyepiece itself. And if enough heat goes through there, it can crack that after a while, and then obviously you can cause damage to your eyesight. Thankfully, I only used it a couple times and then got rid of it because I
Yep.
found out that it was safer to project it on a white screen.
I was about to say,
So-
you can always with binoculars or a telescope put down a poster board or something and project the image onto the poster board.
And the other
Right,
thing to
you
be
can project, yeah.
right, and the other thing to be careful of is don't touch your solar eclipse glasses, because the oil from your fingers can degrade
Can degrade it.
the film cover. And also, don't wipe them clean if you like spilt something on them. I mean, you can destroy them, right? You can thin out the material to the point where essentially they're going to allow dangerous amounts of light to get through.
And that brings up welding glasses. There are certain welding glasses that are rated to where you can use them, but most of them are not. Most welding glasses are not filtered against infrared. And there's the problem. It may dampen down the brightness of the visible light, but the infrared light is still going through and will boil your eye.
Well, did you hear about the new welding glasses they have?
No.
They're adjustable. They change their optical properties so they block out more light if you're doing like TIG welding versus the standard
Wow.
welding.
Huh.
So you can use the one pair. So they electronically adjust for the
That's
light
pretty
intensity. But if you use it on a solar eclipse, you're taking an awful chance it doesn't adjust right,
Right.
and you're blind, right?
That's it.
Yeah.
So I would
Eclipse
never trust
glasses
it.
are not that expensive.
Right.
It's real, yeah. And you hear people, yeah, they'll try and just make something. So they'll find some material that dims it. But yeah, it might look dim enough, but is letting through like the infrared or the ultraviolet. So you
Right.
really want to use glasses that are made for looking at the sun.
And-
Yeah, don't risk your eyesight. Eclipse glasses don't cost that much. Now, people might be scalping them for a
I was
lot
going to
now.
say, so 6 months ago, I bought 6 Eclipse glasses, brand new ones, from a reputable place. Got the ISO number on it, so it's the right number and stuff that's recommended. I only paid like maybe $1 per glass, right? If I was in Niagara Falls on Monday, and if I was a mean person, I'd be selling them for like $40 a pair. 'Cause
Oh, yeah.
you would probably get it.
Oh, yeah. And, as for reputable companies, I'm going to plug a little bit here. Celestron, Mead, Lunt Solar Systems. These are reputable companies. These are ones that, generally speaking, if you go to their websites, they'll have links to where you can buy their solar shades, and they are good. But trusting Amazon, I don't know. You're kind of rolling the dice.
Well,
Yeah.
there is an ISO number on them, and I got mine off of Amazon, but they have the proper ISO number.
Okay.
I checked them all, so they are legitimate. In fact, I've used them already to look at the sun,
Okay.
just to make sure everything was fine. But they got the numbers on it; they're all certified. But there are other types on that you
Yeah.
could buy that are not the right ones. So you
To
have to be
me,
very careful.
the biggest test that I found, because the last solar eclipse 2017, me and some other people tested some, and the big test to me was if you can see anything but the sun through them, they're no good.
Yeah.
And there were people buying solar shades that you could sit there and look at. They were practically just dark sunglasses,
Right.
and it's like, no, that's not good enough.
Yeah. Of course, you could always do the other tests, right, that you don't want to do. You just hand them to somebody and say, okay, now look at the sun, and can you still see afterwards? And yeah, you might get sued for that. So don't do that.
Don't do that. Not even to somebody you don't like.
Yeah. Now, the one thing that shocked me when I watched, my first eclipse was in 2017. What shocked me was the difference from when the sun was, let's say, 99.999% covered by the moon and when it became 100% covered. And that transition, which was showed in your simulation from the simulation from Dallas, that transition to not seeing the corona to seeing the corona was almost spiritual in some sense.
Yeah. And it's sharp. It's dramatic.
It is dramatic as heck. It's so and really, when you think about the corona itself, and why don't you see the corona when you look up at the sun on a normal day? Even though the corona is millions of degrees in temperature, it's extremely hot, it's very, very low density.
Right.
So the total amount of light, the total number of photons, you can think of it from that point of view, coming off the corona is so small compared to the photosphere, that part of the sun that you see with your eyes on an ordinary day, that it gets swamped. It's like looking at a firefly that's, perched on the edge of a spotlight or something.
Right.
Okay, you turn off that spotlight, you can see the firefly, but if it's on the spotlight, you obviously can't see the firefly. It's that sort of transition. And the interesting thing about the corona, number one, is the shape of it. It changes all the time depending on the activity of the sun itself. Mm-hmm. So back in 2017, I remember right, it was like 3 long streamers coming off it, 2 near each other and then one in another location. But I've seen various images of the total solar eclipse, and it has different shapes of the corona. So that can change all the time. So what will be the shape of it on Monday coming up? That's a question.
That's a question.
And the other thing is that the corona, the outer part of the sun, is millions of degrees, yet the heat source, if you like, the furnace of the sun, is in the interior.
It's in the interior.
If you look at the temperature on the surface of the sun itself, on the photosphere, that's on the order of about 5,800 degrees, roughly, Kelvin, but we can round that off for Fahrenheit, still close enough. But when you get further from the heat source, the temperature actually goes up, not down.
Right.
And that's counterintuitive, obviously.
And we're still working on figuring out why. What's
in fact,
supplying the energy.
Yeah, and if you actually go in the news, it just came out in the last 24 hours, there's some new information that was obtained by the Parker Solar Probe, which is this NASA probe that's circling in orbit around these highly elliptical orbits around the sun. And one of the things it's doing is dipping down into the outskirts of the corona itself, making direct measurements. And so as Robert mentioned, what we're trying to figure out is why does that outer part of the sun that's so far away from the heat source in the center of our sun, why is that at such an extreme high temperature? We think it's related to actually magnetic energy, the magnetic field on the surface of the sun. But some of that energy gets funneled into the outer atmosphere, into the corona that heats it up. But we're not 100% sure. In fact, the detailed mechanism of how that works, people are still looking at that
There's
today.
some evidence that it may be acoustic, that it's the motions of the photosphere and the thunder, if you will, that it produces because of its movements that transfers energy.
So when you look at the corona if you're lucky enough to see the corona come Monday during the total solar eclipse, think about that. Think about the mysteries. We still don't know everything. There's still a lot of stuff that we need to figure out. I always tell people, it's not like science knows everything and it's just a matter of memorizing all these facts and things, from textbooks. There's still a great mystery out there.
Right.
The vast majority of things that we study, we still unknown. In astronomy, for example, just think about dark energy and dark matter. That represents 95% of the known universe.
Right.
And we only know about the other part, the 5%.
Yep. And so what's this picture you've got up now, Dean?
Yeah, I finished talking a little bit about if you want to take pictures. So this is, I'll show different exposures. So in 2017, I'll let people know, have cameras and want to know the numbers. So this was a 300 millimeter lens on a cropped sensor. And then this is not the full, image. This is cropped more just around the sun. I think I was using an f number of 5.7. A lot of people, the recommendation is more like f8. I'm not sure, maybe I just didn't know better at the time. But the idea is with f8, it's a little easier to focus. It also cuts down on any aberrations in your lens. So, but this basically, if you did f8, that stops down the lens a little bit. and you basically get half the light. So you'd actually, at f8, you'd have to do double the exposure. So this is 1 millisecond, 1/1000th of a second. At f8, you do 1/500th, it'd be about the same brightness. So this is the shortest exposure I did. And so this was without the filter, right? So basically, when that Eclipse timer app told me I could, I took the filter off the camera. It was already pointed at the sun, and I took the filter off. I had it set up. There is no one exposure, so you want to bracket exposures. You want to learn this ahead of time. Practice it on your camera if you haven't done it. Don't figure it out that
You've got
that
4
day,
minutes.
right? Practice, make sure everything works out, and you know how to set it up. So I had it set up to take multiple exposures and over a big range. And so I'm just going to show them, and then you can kind of get an idea of what it looks like at the different exposures. But again, if you're doing a higher F number, you would have to, like F8, you'd have to double these. And so I actually really like this short one because you can actually see the chromosphere, that little bit of red. So there's a prominence in the upper right there, and on the right, and you can see a bit of the chromosphere. This is I think this is the first set that I did. So this is near the beginning. The moon is moving kind of from upper right to lower left. And so over time, it covered up that red on the bottom left, and you saw more of the prominence on the upper right. That upper right prominence, once the moon had uncovered it more, that's where some people were able to see that visually. And so this is a short one where you can see the chromosphere. Normally, you can see the chromosphere without total eclipse. You have to use a hydrogen alpha solar telescope and it basically just blocks all the light except the red hydrogen light, the hydrogen alpha light from the chromosphere. So the chromosphere isn't that bright. It's just you normally can't see it because the photosphere is so bright. When the chromosphere is a layer above the photosphere, but below the corona. So and we basically just see this red light from hydrogen. So, and put the focus on here. There we go. This is 500th of a second. Now you're seeing that inner corona. The chromosphere is lit up a little bit better. This is probably a nicer picture. Going a little brighter. Now we're seeing more of that inner corona. 1/125th. At a 60th of a second, now that corona is so bright, it's hard to see the chromosphere. This is a 30th of a second. So now we're starting to get the outer corona, but the inner part starts to overexpose. So it's really difficult if you want to get the outer corona. The inner corona, you're down here. You want the outer corona, you start to overexpose. A 15th of a second, now we're really getting further out. And these are unprocessed. These are just out of the camera. I didn't do anything to these. You're also seeing the chromatic aberration in my lens. This is the lens that came with the camera, so it's a budget lens. And so you got the blue and red fringes. Higher F numbers might help with that a little bit. But it only showed up at the long exposure. 1/8 of a second. Now you're getting further out, but yeah, that inner corona is overexposed. 1/4 of a second. 1/2 of a second. 1/2 a second, you are starting to see that the background is not black, right? It's kind of a blue color. You do get more of the outer parts, but you're overexposing the inner parts. So you kind of have to look at your camera, look at the bracketing feature. How many can you take? Some cameras can only do 3, some can do 9, some can do 11. I had some third-party firmware on this camera that let me do 11 different exposures. So,
Oh, wow.
And I did them all. So, but in fact, I think I didn't show them all here. I did a second, but as you can tell, 1 second, then it was just lots of overexposure. But at those longer exposures, that's when you can start to get the earth shine on the moon. So,
Well, you're getting a little bit there, but
yeah, so you are starting to get it. I think even right around in there at a 1/4 second,
yeah,
you can start to see it.
yeah.
1/2 a second. So yeah, so some people will do multi-second exposures to get that earth shine and then kind of superimpose that on
Right.
top. So this is an HDR merge of them, and it's kind of, if you want to get everything, it's still is really hard to get the prominences and the corona because they just get buried in that corona. I always forget what star that was. It was Rigel or Regulus. It was one of the R stars.
So,
Um,
so if you look at this image,
I think it was Regulus.
right. So in this image, the corona, it was those three streamer I was telling you about. So on the top you have the two,
Mm-hmm.
Yeah.
right, and then on the bottom you have the one. And to
Yep.
your eye, it was, I mean, way extended, way beyond this, right?
Right.
It was so obvious, right, to the eye, and you get that whole dynamic range, which the cameras, as we talked about already, can't reproduce. But it was, clearly visible, these streamers, two on the top, one on the bottom. But who knows what you're going to get on Monday?
Right.
Yeah,
You may
it'll be a
just get a
different
little
shape.
Yeah. It may just be a little glow right around the sun.
Who knows?
Right.
So now we are coming up on solar maximum.
So it should be impressive.
So we actually might get more. We might have more prominences,
Right.
than we did in 2017. So,
Yep.
and get it further out. This is cropped right around the sun, and that's where some of those longer, 1 or 2 second exposures might get the, further extended corona. So, but then, you're really overexposing, that
Right.
even at half a second, right? That inner part's really overexposed. So you do have to merge them in software to try and get everything.
Yeah.
Yeah, and it depends what you're interested in, right? You do the bracketing and take the longer exposures if you're looking at the full extent of the corona and wanted to measure the length of them, the angular size, and so on. But if you're, more interested in what's happening right around the edge of the moon, then of course that'd be the shorter exposures. would
Yeah,
be
if you
better
want
for
those
that.
prominences, you got to be down,
Yeah.
like 1/100th of a second. But definitely don't settle on a single exposure. If your camera has the feature to bracket exposures,
Do it.
take a range, and you can kind of use these pictures as as a guide, which ones you want to prioritize.
And
Right.
in the end, folks, if you're not good with the camera, leave it alone. Look at it yourself. There'll be plenty of images on the internet
Yeah.
afterwards.
Don't waste 4
Don't
minutes
waste
looking
4
down
minutes.
at your camera
Yeah,
settings
right.
rather than looking at the
Yeah,
solar
you do not
eclipse.
want to be going through menus and changing things
Right.
No.
during those 4 minutes. Yeah, you want everything set up ahead of time.
And of course, at the moment, the 4 minutes seems like 4 seconds.
It does.
It goes really
That was
quick.
2017. We only had 2 minutes. It was the shortest 2 minutes. I mean,
Yeah.
it was.
Yeah.
It
I mean-
was shocking how fast it went.
The maximum eclipse, I think, it possible is like 7.5 minutes. or
7.5
something,
minutes,
if I
something like
remember
that.
right.
Yeah, totality. Yeah.
Yeah. So, having 4 minutes this time is not bad. And by the way, just for those who are interested, if you want to see another one, you don't want to wait for 20 years or whatever the number is where you live. I mean, you can go somewhere. So there are different eclipses coming up in just a couple of years, different places on the world. In fact, there is a real interesting eclipse that's coming up in July 22nd of 2028. And it caught my attention because the path of totality is going right through Sydney, Australia. And what a time to go visit Australia if you've never been there before, which I haven't. What an opportunity is to plan a vacation in the middle of our summer here in the Northern Hemisphere and go to Sydney and watch the eclipse in 2028.
Yep.
So for those of you who would like to do that sort of thing, there's a perfect place to go.
Perfect. Yeah.
For those who work at a university, it's in the summer. You don't have to worry about canceling classes.
Yeah.
So it's convenient for us. Yes.
I was going to say
So-
it might be expensive going to Australia, but if you look at how much they're charging to fly, within the United States at the last minute here, you're almost talking about Australia type
You're almost,
prices.
yeah.
Right? They want a
Yeah.
lot of money, like $1,500 just to go from point A to point B because you didn't give them 2 weeks notice or whatever that time
Right.
frame is, right? But then do you want to spend money to go somewhere where it's cloudy? Or would you rather wait till the 3-day forecast and then go somewhere where you have a much higher chance of having clear skies?
Absolutely. And so, yeah.
Anyway, so we need to wrap this up for today. So because of the eclipse, we will not be having a podcast next Tuesday. As far as I know, both Robert and I will be on our way back from watching the eclipse.
Right.
The path of totality does not go over Grand Forks, so we have to travel in order to see the total solar eclipse.
Yep.
So we'll be doing that. We'll be in transition next Tuesday. So the next podcast will be 2 weeks from today. So it'll be on Tuesday, April the 16th. And Robert, we have a very, very, very special guest.
Indeed.
The person who'll be joining us on the 16th is Dr. Bonnie Beretti, who actually works at NASA's Jet Propulsion Laboratory. So we have a real scientist, unlike us, right?
Unlike us.
Just kidding. She is also a deputy project scientist for the Europa Clipper mission, which is a spacecraft that'll be launched in October, if it keeps to the schedule, that'll be heading towards Jupiter and actually doing detailed measurements of Europa, possibly looking for signs of life.
Right.
So that'll be very
Definitely
interesting.
looking for signs of liquid water.
Yeah. So the 16th of this month, we're going to have very special guests. So that would be, if you can join us at that time, that should be amazing. Should be a real good podcast.
I'm going to take a moment. We did get a last minute question in. Astronomy Lover asks, is there a list of total eclipses that is easy to find?
That timeanddate.com website does
Okay.
have a list. So the same place where you can go to the eclipse map, that they have future eclipses too. And I think you can even search by country and year and stuff.
Cool.
So
Yeah, neat. Now, before we finish here, first of all, thank you very much for doing this, Dean.
Indeed.
And we always leave you with a quote or an excerpt. And so I have an excerpt for today. It's actually from Homer's The Odyssey.
So we're going to go on a journey.
This is way back in the 8th century BCE, a long, long time ago. And there's a part in the Odyssey which, as far as scholars say today, it actually represents a solar eclipse, a description of a solar eclipse that happened on April the 16th, way back in 1178 BCE.
Nice.
It's a long, long time ago. And here's the part. It's relatively short, but here it is. And the sun has perished out of heaven, and an evil mist hovers over all.
Nice.
Thank you very much for watching, and we'll see you next time.
Thanks, folks. You have a good day.
bye.